So in this video and this assignment, it's going to be a lot of review of what you did in Algebra 1. That's why we can do it independently. So we're going to have you watch this video and work on the homework kind of on your own here. But three major learning targets. One is, they all have to do with linear functions. One is just writing a linear function and graphing a linear function based on a given situation. Same thing, the second learning target, except this time you're not going to be given the situation, you're just going to be given 2 points and you'll have to write the linear function to make predictions. And then finally, we're going to be able to graph linear inequalities and apply them to different situations. Inequalities are the same thing as equations, only with less than or greater than signs. So let's go ahead and get started with our first example. Just write a linear equation for Allie's profit after selling X number of hats. So it says after buying all of her supplies for $135, Allie began selling her stocking hats for $12 a piece. So this should be $35 here. $135. So she started making these hats and selling them for $12 a piece, and she's starting her own little business doing this. And so we're going to write an equation for this. Her profit, I'm going to let that be Y, and that's going to equal $12 for every hat that she sells. That's her, this is her slope. Every hat that she sells, she gets an additional $12, but she had to spend $135 just to get started. That's her y-intercept. That's where it starts. So if we were to graph this, it would really look something like this. We'd be down all the way down here at negative 135, and every hat she sold, she would get $12 more, and it would go uphill and look something like this. She's going to start off in the red, in other words, losing money for a while, but it'll be a while before she starts to make a profit. But once she does, she'll be off and rolling because she'll have paid off her debt of $135, and then every hat that she sells would be $12 more in profit that she makes. But this is the linear equation we would use. Well, we would want to use that linear equation then to answer this question. How much profit would she have after selling 25 hats? Well, we would just plug 25 in for X, which represents the number of hats that she would sell, and it's going to be 12 times 25 minus 135. Well, 12 times 25 is 300, and 300 minus 135 is $165. So we can do that because we can write a linear equation for that situation and graph it and then answer it to, or use it to answer questions or make predictions about things in the future. See what you can do on number 2. What I would encourage you to do is pause the video right now, see if you can do number 2 on your own, and then you can restart the video and see if what you did was correct. Hopefully you did that. Here's what it says. Write a linear equation for the amount of water left in the Southwest Allen County Schools natatorium after X hours. So when the pool is full, it holds 192,000 gallons of water. But when they empty the pool, they can only take out 2,800 gallons every hour. So the equation is going to look something like this. We're going to have a slope of negative 2,800 gallons every hour. That's how much water they're pulling out of the pool every hour. But it started with 192,000 gallons of water in it. Boy, that looks messy. So 192,000 gallons. That's our y-intercept. That's where it starts. Graphing this equation would look something like this. We started with 192,000 gallons of water, but every hour we lose 2,800 gallons. So it's a negative slope. It's going downhill. So how much water will be left after 48 hours of emptying? Well, we're going to take negative 2,800 times 48, which is 2 days, plus we started with 192,000 gallons. So negative 2,800 times 48 is 134,400 gallons have been taken out, plus it started with 192,000 gallons. If we add those together, we still have 57,600 gallons of water left in the pool after 2 days of emptying. So that's writing a linear equation based on situations. So let's change and move to, instead of from situations, let's go to given 2 points. We're really doing the exact same thing. We're just given a different type of information. So here's what it says for number 3. Tim's lawn mowing business has been profitable this summer. However, after mowing 18 lawns, he only had a total profit of 20 bucks. That doesn't sound very good. But after mowing 33 lawns, his profit was up to $395. So how did that happen? Well, it all has to do with a linear equation and his expenses that he must have had before he started his business. So let's just take a look at this. We have one point that is this. After 18 lawns, his profit was 20. However, after 33 lawns, his profit was $395. Those are our 2 points. The first thing we have to do is find the slope. So let's make sure we know how to do that. Remember, your slope equation is y2 minus y1. So that's 395 minus 20 over x2 minus x1. And that's 33 minus 18. So for our slope, 395 minus 20 is 375 over 33 minus 18 is 15, and 375 divided by 15 is 25. So that means that he gets $25 per lawn. That's his slope. He makes $25 every lawn that he makes, but it doesn't make sense if after 18 lawns he only made 20 bucks. Well, that's because he had some expenses at the beginning. And so let's figure out what this is. You might, there's different ways of doing this, but the way most teachers teach it here at Homestead is to use the point slope formula. That's the formula that looks like this. y2 minus y, or y minus y1 equals the slope times x minus x1. In other words, we're going to have something like this. I'm going to have y minus the y value. I'm going to use this point. It doesn't matter. I could use either point. I'm going to take y minus the y value, which is 20. That equals the slope, which is 25. That's what I found over here, times x minus the x value in the point that I chose, which is 18. So this is going to be y minus 20 equals 25x minus 450, because 25 times negative 18 is negative 450. Then if I add 20 to both sides, my equation is simply going to be this. Y equals 25 for every lawn, but then if I add 20, it's going to be minus 430. What that means is he must have spent $430 on equipment, maybe his lawnmower, maybe his trimmer, maybe a weed whacker, on just supplies that he would need in order to start his business, to start to make money. And so there's our equation. It's going to get kind of messy, but then it says use your equation to predict his profit after mowing 50 lawns. Well, we would just plug 50 in for x. If we take 25 times 50 and then subtract 430, that would mean that he would make a profit of $820 after mowing 50 lawns. This is what you would need to be able to do with linear functions. So let's take a look at a different situation. Number 4 is a little bit different because I'm not going to give you 2 points like I did here. Here I gave you 2 specific points. But let's read it and see if you can figure out what type of information you are given here. It says Samantha chews 6 pieces of gum per day at school. We know that after 11 days she still has 384 pieces left. So she must have a whole backpack full of gum. I'm not sure. It says write a linear equation for the number of pieces of gum she has left after X number of days. Well, we already know that she chews 6 pieces a day. That's your slope. Okay? And it's going to be negative because that means 6 pieces are gone every day. So her slope, which is M, is negative 6. And they gave us a point. We know that after 11 days, she has 384 pieces left. So we're going to use the same equation that we used over here. That's called the point slope formula. We're going to take y minus the y value, which is 384. That equals the slope, which is negative 6, times x minus the x value, which is 11. So we're going to have y minus 384 equals negative 6. And then negative 6 times negative 11 is positive 66. And then we're going to add 384 to both sides. So we'll end up with y equals negative 6x plus 384 plus 66 is 450. That 450 must mean that she started with, that's your y-intercept, that means she started with 450 pieces of gum. Maybe at the beginning of the year, and she just goes through it like crazy. So that's our linear equation. And then we can use that equation to predict how many pieces she'd have left after 31 days. Maybe that's the first month, I don't know. But after 31 days, we'd plug 31 in for x, multiply it times negative 6, and add 450. That means she's still going to have 264 pieces of gum left after 31 days. So that's what you would do. That's how you would write a linear equation given either 2 points, or in this case, the slope and a point. So what we haven't done yet is the inequalities. So let's just take a look at these two inequalities first. First one, number 5. When you graph equations, remember y equals mx plus b. The b is the y-intercept, so in this case the b is going to be 4. We're going to start right here at 4. The slope is negative 2/3. We're going to go down 1, 2, and over 1, 2, 3. Down 1, 2, and over 3 again, and we know it is going to look something like this. And I'm putting a dotted line in there because of the fact that this is less than. If this was an equal sign, I would just graph this line and I'd be done. That would be my graph. But because of the less than sign, this graph is just a boundary line. All of these points do not make the equation true. If I were to plug in 3, 2, which is this point, it would not make this equation true. It would be a boundary line. But I want the y values that are less than that. Well, here's the y values along the y-axis. I want the y values that are less than this. Well, those are going to be all the y values below the y-intercept. That means not only everything below this y-intercept is going to make the equation true, but all of the points below that line are going to make the equation true. For example, 0, 0 is going to be one point that makes that equation true. If I plug a 0 in for x, I'm going to have negative 2/3 times 0 plus 4. That's going to be 4. And if I plug a 0 in for y, I'll have on the left side of the equation, 0 is less than 4. So this point makes that equation true. All of these points over here will make the equation true, and that's why those points are the solutions to that inequality. So it gets a little bit more difficult when the inequality is not in slope-intercept form, but standard form like this. If it's in slope-intercept form, we can just tell right away this is going to be a dotted line because it's less than, or because it's not equal to, and it's going to be shaded below the line because it's less than. We can't tell that specifically from looking at this inequality because it could change. So what I'm going to have to do to graph this is I'm going to get it to look like this. I'm going to put it in slope-intercept form. So I'm going to start by subtracting 4x from both sides, and I will have negative 6y is greater than or equal to negative 4x plus 12. I just wrote the negative 4x first, and that's a plus 12 there. Then I'm going to divide everything by negative 6. But when we divide everything by negative 6, we have to remember that this sign changes because I divided by a negative number. So it's going to be y is less than or equal to, that's 2/3 x, and 12 divided by negative 6 is negative 2. So this is going to start at negative 2, and the slope is going to be up 2 over 3. It's going to be a solid line this time because there's an equal sign there, so it includes the line, and it's less than that. So y is the less than or equal to everything over here. And so that graph is going to look like this. Well, that does it for this video. That's all about linear inequalities. There is a homework assignment in Math Excel that you can do once you finish watching this video, and we will go over questions that you have tomorrow in class.